Hello everyone, welcome to our Biostats series, and today we're going to discuss about two extremely important topics that you may see on your exam, which is the positive predictive value and the negative predictive value, commonly known as PPV and NPV respectively. Many students memorize the formulas but then get confused about when to use them. And by the end of this video, you'll understand the logic behind PPV and NPV, and the most important thing is to know how they differ from sensitivity and specificity, because that is where the real confusion lies. And you'll also be able to solve the exam questions really quickly because we'll do some practice questions at the end. So let's get started. So as we discussed in our previous video, an invented tooth scan X would be a new test, which is made to detect oral cancer. So before using this test in clinical practice, we usually want to know whether its results can be trusted or not. So to understand that, let's first recap on what we learned in the earlier videos, which is sensitivity and specificity. And we learned that sensitivity is if a patient has oral cancer, how likely is the test, which is the tooth scan, to detect it? How likely can the test detect the oral cancer? That is sensitivity. And it talks about the diseased population in the cohort. And specificity is the exact opposite, which talks about the disease-free, or how likely is that tooth scan X, which is the test, how likely is the test to identify disease-free or basically healthy population. So we studied both these things, and then we also notice here how we know that the patient has the disease first, right? And the easiest way to remember is, do I have the disease first or the test first? And we're going to look at that in a minute. So what essentially we look at when we are looking at sensitivity and specificity is that we know the person is diseased, and then we check if the test did well in diagnosing that disease or diagnosing a healthy person as disease-free. So we talk about the disease first, and we're sure that a person has a disease, and then we are basically seeing how well the test is doing in identifying or not identifying that disease. So let's move on to the opposite of sensitivity and specificity, right? So we see that here we're talking about the test first instead of the disease. So we're kind of flipping the direction of what we learned earlier. And instead of starting with disease, we're starting with the test result. So imagine you're a dentist and a patient walks into your clinic carrying a report, and you don't know whether the patient really has the cancer or does not have cancer, right? And in sensitivity and specificity, we were very sure that the patient had or had not the disease or did not have the disease, and we used to check if the test is doing well enough to identify that. But here we have the test which either has a positive or negative report, and now we are checking if the test is correctly telling us or if that the patient has the disease or not, right? So the question becomes here, can we trust this test result, right? So essentially, in easy language, what it's trying to tell us is that we have a test report which is negative or positive in a definitive manner, and how much can we trust this test to tell us if this patient is diseased or not. So if a patient comes up to you who potentially has a lesion that you think is oral cancer, how confident are you that your test is telling the truth that this person has oral cancer? And on the basis of that test, of course you're gonna medicate the patient or plan a treatment for the patient. So you gotta have a solid test, right? So basically that is exactly what positive predictive value and negative predictive value tell us. They tell us if a test can predict a diseased patient, rightly so or not? Can we trust the test or not? Can we trust the test to tell us that the patient is diseased or not? And of course, you want a test which has a great prediction, right? The test is predicting if the patient is diseased or not. So you want a test which predicts the values or predicts the report to be an absolute. And you want that to be correct because you're going to base the treatment plan off of your test. So I'm sure I'm just making you see the 2x2 table, because to understand PPV and NPV, we also need these 4 terms, these 4 friends of ours that we saw in the last video, which is true positive, true negative, and then false positive, and then false negative. I'm sure you remember this. If not, you can look at our previous videos and you can come back to it after you review that. Alright, so now that I have given you a kind of difference between sensitivity and specificity and positive and negative predictive values, let's look at them individually. So positive predictive value is, let's say the patient's test report comes back positive for oral cancer, right? The first thing we want to know is, what is the probability that the patient actually has oral cancer, right? And that probability is known as the positive predictive value. So as we see, let's take an example. So we have, let us say, 200 people in a cohort, right? And out of this 200 people, we have a gold standard test, which is always correct, which tells us that there are 60 diseased people and then there are 140 healthy people, right? So we can kind of say that this test, which is tooth scan over here, which is our hypothetical test, that is telling us that out of these 60, it has identified 40 people to be diseased, as truly diseased. So we can say that this 40 is a true positive value, right? And our gold standard here is telling us that there are 140 healthy people, and out of these 140 people, tooth scan X is telling us that 130 people it has identified as healthy, right? So that means that these 40 people are actually our true positives, because it has truly identified them as positive, and the gold standard also says that they're positive. But we have only 130 people who are healthy are identified out of a 140. That means 10 people out of these, or out of 140, are left out by the test, or the test was not able to identify, this test was not able to identify these 10 people as being healthy. So these would be the people that the test has set to be positive. So they're actually healthy, but the test says they're diseased, and hence this is known as a false positive, right? So we have true positive 40 people and then false positive 10 people, right? So whenever we're speaking about the positive predictive value, we only care about the positive values, be it true positive or false positive, right? So out of these 50 positive results, right, how are they 50? So we add all the positive results, the true and the false positive, and we get 50, which is 40 plus 10. And out of these 50 positive results, how many truly have oral cancer, right? So that is the positive predictive value. Out of these 50 people, how many actually have oral cancer, right? That is the positive predictive value. So if we look at the formula right here, as you can see, it is kind of similar to the formula of sensitivity. But the formula of sensitivity was true positive divided by true positive plus false negative. And that is where it is different from the formula of positive predictive value, right? Because in positive predictive value, we only talk about the positive. So true positive plus false positive are all the people who tested positive, right? Whether it be true or false, we don't care about that. We just care about the fact that people tested positive, right? So let's calculate our previous example, the answer of our previous example, right? So we had 42 positive people, and then we had 40 plus 10 false positive people, which is 40 by 50 in 100, which is 80%. So our positive predictive value will be 80%. Now, what does this value mean? This value means that if the patient's report is positive, there is an 80% probability that the patient has cancer. So that means that in actuality, the test that we had, right, the positive report of the test is only 80% probably correct, right? And we have that 20% of doubt still, right? So this is telling us what is the probability that the patient is positive if a test tells us he is positive, right? So that is something you need to understand, that first the test result is known to us, and then we see if the patient is diseased. And that is exactly what positive predictive value and negative predictive value is, right? All right, so now that we know about this, we can move on to negative predictive value, which is pretty much similar to what we just did, right? Only here, we're not talking about people who have oral cancer. We're saying if you get a test report of a patient and the test says the patient is negative for oral cancer, right? So what is the probability that the patient does not have oral cancer, right? We're basically checking if the test, what is the probability that the test is right? So if the test is right, the patient will not have oral cancer. So to what degree is the test correct that we can say for sure that the patient does not have oral cancer? Let's take an example again. In the same cohort of 200 people, right? So this is the same cohort, and our test, which is Tooth Scan X, has identified 40 out of 60 people as diseased and 130 out of 140 people as healthy. So we can say that people who are identified as healthy for sure were 130, and hence this value would be a true negative value because people are negative for the disease, right? And this test of ours has identified 130 of them to be negative correctly. So it's true positive. It's true that they're true negative. So it's true that they're negative. And talking about the other side of negative, which is the false negative, and how we will calculate that would be that 20 people, if you minus 60 minus 40 would be 20 people which this test failed to identify as diseased, right? So these are the 20 people that the test did not identify, and they would be false negative because they're actually positive, but the test says that they're negative, and hence these would be the false negative. So let's total all of the negative results, true plus false negative, which is coming out to be 150, right? So we can say that out of these 150 negative results, the people who are actually or truly cancer-free or do not have oral cancer, that value will be the negative predictive value, right? So let's move on to the formula and actually look at the formula, which is pretty similar. So here we're only concerned about the negative values in total, right? So we're going to look at true negatives upon true negative and false positives. So if you compare this with the formula of specificity, right? So the formula for specificity is true negative divided by true negative plus false positive, and this is where the difference comes, right? So you can compare it right here, and then we can just look at that, and we can try to solve the previous example that we saw on the previous slide. So according to the example, According to the example, we could put in the values. So true negatives were 130 upon 130 plus 20, which were the false negatives. And if we divide this, the answer in percentage comes around 86.7%, and that's the negative predictive value. So what does this exactly mean? It means that if a patient's report is negative, there is a 86.7% probability that the patient really truly has oral cancer, and the rest of the percentage of the patient would probably be a doubt. So it's not 100% predicting the results well, but it is 86.7%, almost there. So these are basically the two formulas of negative and positive. So the first question says that a new salivary diagnostic test is developed to detect oral squamous cell carcinoma, and in the study 150 patients tested positive by this particular test, and then they evaluated using a biopsy which confirmed that only 120 patients were in fact positive for oral cancer. So what is the PPV? So you can pause the video and try solving this yourself. So let's solve it together. And the first question that I ask myself in these questions is, what statistic are they asking? So if they're asking for the positive predictive value, I immediately think the positive test first, and then we ask how many of these positive people truly have the disease, right? So that means the true positive people are 120, because in actuality only 120 people are positive as confirmed by the gold standard, and 150 would be all the positives, right? That would be true positive plus false positive, excuse me. So all of these values are enough to tell us what the positive predictive value is, and if we plug this in the formula, we get 120 divided by 150, which is into 100, which is essentially 80%. So our answer is 80%. Let's move on to the next question now. And the question says, a chairside test is used to detect early stage oral cancer, and the test has a PPV of 75%. So if 200 patients received a positive result, how many patients truly have the disease? Now, if you look at the wordings right here, they're asking for the true positives, right? Because the 200 of these patients have received a positive result from the test, which does not mean that they're actually positive, because the positive predictive value is only 75%. That means there is still 25% doubt that these 200 patients, out of these 200 patients, some of them are wrongly diagnosed as positive, right? So they have given us the true positive plus false positive value right here, and then they have given us the PPV, which is 75%, and they have asked us how many patients truly have the disease, which means they're actually asking how many true positives are there. So we can just plug this easily in the formula, and then we can calculate all of this, right? So if I cancel this right here, 75 into 2 is the true positive, which is essentially 150, and that is the answer. So you can get questions that do not directly ask you the PPV, and they ask you one of these other values, and you can easily take them out by using the formula. All right, let's move on to the next question. So the next question states that a clinician receives a report stating that a patient's screening test for oral candidiasis has tested positive. So which of the following statistics would be the most useful in determining the probability that the patient actually has oral candidiasis? So notice how in this test, right, this is a pure concept questions, there are no calculations, so we need to know that do we know whether the patient truly has the disease? No, we do not know if the patient truly has the disease. Do we know the test result? So the answer is yes, we know that the test has resulted positive, right? So what we know is the test result. This means that this is either a PPV or an NPV question, right? Because we know the test result before we know if the patient has the disease, right? So let's see, whenever we start with a positive test result and we want to know the probability of a disease, we're basically talking about the positive predictive value, because this only talks about the positives, right? So let's see if any of these fits this the statistic that the question is asking. So sensitivity is the patient has the disease, and we ask how often does this test become positive. So first of all, we're not looking at the disease at the moment, right? First we have the test, and that is the only definitive value we have, so it cannot be sensitivity. On the same lines, it cannot be specificity, because specificity asks that the patient is healthy and how often does the test become negative. So definitely this speaks about the test being negative, and that cannot be the case. Let's look at D. D, if it was negative predictive value, it would never say that the test is positive. The test would have been negative, right? So in that case, we can rule out all these three options, and we can say that positive predictive value C is the right question, because the test has said that it is positive. And then to determine the probability that the patient actually has oral candidiasis, we would predict a positive result, which would be a positive predictive value. All right, moving to the last practice question, which is, which of the following best describes the difference between sensitivity and the positive predictive value? So this is another conceptual question that you may get on your exam. So we need to be extremely clear on our concepts, right? So let's start. So let's think about sensitivity first, right? So sensitivity says disease first, and then we will see if the test has performed well or not, right? So sensitivity starts with a positive test result, whereas PPV starts with the disease status. That is incorrect, because sensitivity is the one that starts with the disease status, and PPV is the one that starts with the test result first. So that's clearly wrong. Let's look at the second one, which says sensitivity starts with the disease status, whereas PPV starts with a positive test result. So this is the one that's actually looking right to me. And the other one says both start with disease or both start with test results, which is simply not true, right? So the answer would be B. Now that we've discussed all about NPV and PPV and also practice some questions, you might want to review the questions and the formulas once again, just to tighten the concepts. Thank you for watching our video. In the next video, we'll be talking about other concepts like type 1 and type 2 error and other important ADAT questions as well. So stay tuned, and let's see you in the next video.